Hi class, Dr. Searcy here with the first lecture of the semester. As you can see, the class is Psych B5 Elementary Statistics for Behavioral and Social Sciences. I'm Dr. Searcy, and these are your set of lecture notes for Chapter 1, which is an introduction to statistics. So the way I want to begin is by just introducing what statistics are in general. So I have the word statistics here, and the definition for it is that statistics are methods to organize, summarize, and interpret data. Okay, so I'm not sure if that definition means very much to you, so I kind of want to give an example of what we mean by this. Let's think of the world that we're living in right now. The way the world is, particularly here in the United States, there's a lot of things going on that are of psychological research interest to psychological researchers. Specifically, I'm referring to the fact that we are living in an unprecedented time of the coronavirus, which is affecting all of us. Many psychologists are currently interested in studying how is the coronavirus impacting people with regard to their mental health, right? Their psychological well-being. One way that we can think about that is look at one way that the coronavirus has impacted my life and your lives, right? It basically has emptied out the physical classroom. We can no longer meet in public spaces for hours on end because we might get sick. Psychologists are interested in studying, well, how is that impacting people? Is it causing anyone to be depressed, to experience anxiety? Or is it not having that kind of effect on people? So the way that the psychologist is going to get those questions answered is they're going to go out to participants out in the field, and they're going to ask them how they're feeling. And then they're going to get that information. Once they've got that information, they're going to organize it. Right? And by organizing, we're saying they're going to get a sense of all the answers they got from all the different participants. Maybe they'll do calculations like averaging different kinds of answers, those kinds of things. But once they've done that, then they're going to summarize all of the information so that they have a sense of what their participants told them in general. And then from there, they're going to interpret that information. What does this information mean? Okay, so now there are a couple of ways that we have to think about how these statistical analyses are conducted. First, let's think about the example study that I've been talking about here. A psychologist is interested in studying the psychological health of students. And let's say maybe those students are all Bakersfield College students, right? The psychologist is interested in looking at how is the pandemic affecting the psychological well-being of all Bakersfield College students. When we talk about the study in terms of all BC students, one thing that we want to recognize is that we're referring to a specific group of participants, right? The BC student. And one way that we can refer to that group is as a population. What is a population? A population can be defined as everyone in a group being studied, right? So in this example, all BC students are the population of interest. All BC students are everyone in this group that we're interested in studying. One thing that you want to think about with that, though, is that it can be troublesome for the researcher to reach every single BC student. I looked up the number of students over on Wikipedia, and Wikipedia says that there are 22,000 students currently attending BC. It would be hard to go out and ask all 22,000 students, how are you feeling, right? It would be expensive for the researcher to make contact with all those students. Some of those students may not be reachable. Other students may not want to respond. And so it's going to be almost impossible for the researcher to get to everyone in the population. Now, the researcher knows this, right? That it's going to be that hard. And it's going to be this task that is insurmountable, almost impossible to achieve. So what the researcher is going to do instead is, instead of going out and trying to gain access to everyone in the population, the researcher is going to identify a sample within that population and contact everyone in the sample. So what is a sample then? Well, a sample is some group that's selected from a population. Let me give you maybe a visual example of how this might work. Let's say if I draw this circle here, and I say that circle represents the population. What we mean here is that it represents all BC students. But like we're saying, the researcher can't get to everyone in the population, so instead the researcher is going to make contact with a sample. We're saying that sample is some group that's selected from the population, right? So it's some group that's a part of the population that we're going to make contact with. Maybe in this example that we're talking about, this sample could be this class, right? Everyone in the class is a BC student. You would be representative of the population. So the idea here is, the original question is, how is the psychological well-being of the BC student? We can't make contact with all BC students, so instead we're going to collect a sample and we're going to ask them, how are you feeling? And the idea is, you will resemble the population so we can consider your answers to be representative of the population. What you say would be representative of all BC students, right? And the idea is that you're a typical BC student, and so you represent what the typical BC student would say. Okay, so that's the general way that statistics work. From here, I just want to go ahead and add some clarifying points. One clarifying point is that there are characteristics to each of these types of analyses, right? So an analysis where you're looking at the population versus an analysis where you're looking at the sample. The thing that I want to say here is we would give two different names to the two different types of analyses. If we are doing an analysis on the population where we're actually able to contact everyone in the population, then we would refer to that analysis as a parameter. On the other hand, if we're just doing an analysis with our sample and we're not thinking about everyone in the population, then we refer to that analysis as a statistic. Okay, so that's just some jargon that we need to be aware of, right? How we name certain things. From here, I now want to talk about something that happens that's referred to as sampling error. Sampling error has to do with the difference between a measurement with the parameter versus a measurement with the statistic. Basically, we would define a sampling error as the difference between a parameter and a statistic. This may not make very much sense to you right now, so I want to do another example where I kind of illustrate this idea. Let's say a researcher gathered both types of measures. They went out and were able to contact everyone in the population, so they obtained some kind of parameter measurement. That same researcher also went and contacted a sample from the population. So they've also got some measure of a statistic as well. Let's say that the researcher comes away then with two different types of measurements, a population mean and a sample mean. By the way, I'm using the word mean here to mean average. Okay, so let's say that when the researcher went and contacted the population, that researcher made contact with 22,000 BC students. Right, remember what the researcher was doing was they were asking, how depressed are you? And maybe the way that the researcher did it was they said to all the students, tell me how depressed you are and tell me on a scale of 1 to 10, where the number that's closer to the 10 is saying that you are very depressed. That's supposed to be an unhappy face. And if you give me a number that's closer to a 1, then that's saying that you're not that depressed, maybe even you're kind of happy. Okay, so let's say the researcher went, asked the 22,000 students, how depressed are you? Give me one number that represents your level of depression. And then the researcher goes and calculates some average score for all 22,000 students. And the researcher finds that the average or the mean depression score is 6. Right? So on average, the 22,000 people that were the students said that their depression level was a 6. Now let's look at the other measurement the same researcher could have done, right? So they also went to a sample. They went to some group within the population and they asked them the same question. This time in the sample, it was, just like we were saying before, everybody in this class. I looked up how many students I have in the class at this time, and there are 24 of you in here, right? So everybody's a BC student in the population and in the sample, but whereas in the population there are 22,000 students, in the sample there are just 24 students. And I asked the 24 students the same question, how depressed are you? Tell me in terms of this scale. And for the 24 students, their average depression score was 7. Okay, now this is all hypothetical, completely made up, but we're using it as an example of how to talk about sampling error. Okay, so the measure of interest was how depressed the individuals were. The population said 6. The sample said 7. So there is this difference between what the population told us and what the sample told us. This difference is a difference of 1, right? 7 minus 6 is 1. That difference is what's being referred to when we talk about sampling error, this difference between the parameter and the statistic. Okay, now I want to go ahead and move on to some other important bits of information. Next thing we want to talk about is this idea that when we talk about statistics, right? So when we talk about getting information from a sample and doing some type of analysis, we want to recognize that there are 2 types of statistics that the researcher can do. The first of these 2 types of analyses are what are referred to as descriptive statistics. These can be defined as where the researcher is going to have collected the data and then they're going to do that organizing and the summarizing part, right? So an example is they'll take the data and they'll calculate the mean, just like we did here. Notice that this is a type of organization and summarizing in that it gives you a sense of what this group told you compared to what this group told you. Other thing that you might want to notice here is that I'm saying this is something that the researcher is going to do first, right? When they after they've gone and they've asked their questions, this is the first analysis that gets done. The descriptive analysis gets done first. Once that has happened, though, then the researcher can move on to do the second type of analysis, the inferential analysis. And this is where now the researcher is going to make inferences from the data. What do we mean by inferences? We're saying that the researcher is now going to make conclusions about what the data is saying. And one way that we can do this is to calculate what's referred to as a t-test. Let's just also note that this is the thing that the researcher is going to do second. It's the thing that they do after they do the descriptive analysis. Now, I don't want to go too much into either of these two types of statistics. These are basically what we're going to learn about this semester. I'll just give you a sense of how we're going to learn about them. We're going to spend the first couple of weeks learning about descriptive statistics, what kind of descriptive statistics there are, why we do them, and how we do them. But then after we've covered that, I think it's after chapter 6, then we're going to move into the inferential statistics. And this will basically cover the middle to the end of the semester. But let's go ahead and just stick to introductory stuff today. Right, I just want to give you a sense of what statistics are and how we use statistics in this lecture. So the next thing that we're going to talk about is statistical methods. How can researchers conduct their analyses? A first type of statistical method that we can talk about is the correlation. This is defined as where the researcher measures whether two variables are related. Now, at this point in the lecture, I've just introduced another semi-new term, and that semi-new term is variables. I'm calling this a semi-new term because it may be something that as a student you've heard about in the past, right, what variables are, but you may not have gotten quite a solid definition of what a variable is. So I'm just going to offer a quick verbal definition of variables right now. Basically, a variable is anything that can be measured, right? Anything that's of interest to a researcher that is measurable. An example of this is these depression scores that we're talking about. Level of depression is a variable because a person's level of depression is something that is measurable. Okay, but notice in this definition here, what we're saying is that when someone conducts a correlational analysis, they're looking at two variables at the same time. And they're asking, are these two variables related to each other? So let me give you an example of how this kind of analysis would look. Let's say that a researcher is interested in measuring what we've been talking about before, level of depression, right? And we're even using the same that we talked about up here. Level of depression, where the closer they are to the 1, the more happy the person is. The closer they are to the 10, the less happy they are. But what's happening here is that is the second variable, variable 2, in this analysis. The first variable of interest, this V1 here, was where the participant was also asked, how long have you been a BC student? Right? How long have you been a student at Bakersfield College? Now, the students in this class might have an interesting answer to this question. How long have you been a BC student? My guess is that if you're a student in this class, you've been a BC student for longer than a semester, maybe even longer than a year, right? Because it seems like this class is something that you take later in your BC experience. But what we're looking at here is, are these two variables related to each other? Right? The question I'd be asking here is, does length of how long a person has been a student have any relationship to how depressed they are? One way they could say this is maybe students that are new to BC, have not been BC students very long, maybe they are more depressed than students who have been BC students for a long time. And the idea, but my rationale there is, if you're a new BC student, right, maybe like you started last year, you were looking forward to having the college experience, you were looking forward to being out of high school, and now being somewhat of an adult, right, going to college. And you've been cheated out of all of that by the coronavirus. And so because you're a younger student and you're missing out on all these things that you thought you were going to get, you're more depressed. On the flip side of that, right, if you have been a BC student for a longer time, maybe you're less depressed, right? You're going to have a score closer to 1 because you're seeing this pandemic experience as maybe a break from the studies that you were, or the classes you were taking. You're almost done. You're almost like taking a year off. And you're using this year to grow. Okay, all of this is speculation. All of this is just theorizing. But it's a theory of how this variable might be related to this variable. And I'd love to hear if anyone here agrees that these two variables might be related or unrelated. But let's go ahead and move on from here. Okay, so we've just talked about one type of statistical method, the correlation, and we've gone over the example of how it would work. Let's now talk about a second type of statistical method, and that is the experiment. Here, I'm defining it as where a researcher does something to a participant, right? So a researcher has prepared some intervention, some way to have some impact on the participant. In the experiment, the researcher does that thing to the participant, and the whole point of doing the thing to the participant is to then measure the participant's reaction. How does the participant react to the thing that the researcher has just done to them? So what's an example of this? Oh, a nice example would be where, again, the researcher has two different variables. Here I'm noting that one variable is called the IV, and the other variable is called the DV. I'll explain what these two variables mean in a couple of minutes. For right now, we'll just say IV stands for independent variable, and DV stands for dependent variable. So the independent variable, that's generally what the researcher does to the participant, right? That's what this is. And as an example, we're talking about depression. Maybe what the researcher has done is they've gone and they've administered some antidepressant to a group of participants. Maybe this is a new antidepressant that just got produced, and the researcher wants to test the effectiveness of this new antidepressant. So they give it out to this group of participants, and then the dependent variable is where they're doing this part, they're measuring the participant's reaction. The way that they're measuring the reaction here is they're measuring the effect of the antidepressant on the depression, right? So crucial to understanding what an experiment is, it's where a researcher does something to a participant, that's the thing that's being done here, and then the researcher measures the reaction, that's this part here. Okay, so at this point, we've just explained two types of statistical methods, the correlation and the experiment. Now, I want to move on to, let me cover this up, to different types of measurement categories. What do I mean by this term measurement categories? Here we're talking about basically how to organize the data. Right, this is like even in terms of when the researcher is setting their study up, they're creating the study. They know that they're going to do something to participants. Maybe they're going to ask them questions. Maybe they're going to do something to them. Regardless of whether it's a correlation or an experiment, the first job of the researcher is they have to figure out how are we going to do the things that we're going to do to the participants? How are we going to organize the information that we're going to get? As it turns out, there are 4 different ways that this organization can be done. Those 4 different ways are often referred to as the noir system. The reason why they call it noir is because this is an acronym for the 4 different ways. And I'll just kind of note what those 4 different ways are, right? We have, they can create nominal data, ordinal data, interval data, or ratio data. And that's where we get the noir. It's just a nice way to remember what the 4 ways are. Okay, but let's talk about each way individually, beginning with nominal data. Right, so here we're saying that nominal data is where the researcher has organized the data in terms of categories. An additional note that we have with this is that when the data is organized this way, there is no information on magnitude or direction, right? So we have no information on like how much is happening of something or in what direction those things are going. But I do want to take a moment to just kind of give you some examples of what this would look like, what nominal data would look like. One example is we can go up and we can ask students questions and organize their answers according to things like, put example here, examples here. We can say that they could organize data according to things like maybe GPA, right? So grade point average. Another way that we could do it is maybe we can organize data according to stuff like a student's major, right? This would be kind of interesting. Like we could go up to students and we could get a sense of how depressed all the students are, but here we can organize level of depression according to major, right? So we could find out how depressed are biology students versus how depressed are psychology students versus maybe how depressed are acting students, right? And it'd be interesting to see, is there a major that is more or less depressed than another major? I'm thinking an answer you might get with this is for the majors where those students can easily complete their classes via Zoom, those students are going to be less depressed, right? Like our psychology students. A major that might be more depressed would be students who can't create or can't complete their classes quite so easily using Zoom. Like maybe a theater student who really has to have that face-to-face interaction, like in an acting class. Or maybe like a ceramics student who needs to have access to their ceramics equipment in the ceramic class, like, I don't know, the kiln where they bake their creations, right? Maybe because those students don't have access to those things, their classes are not as easy to complete, and so they're going to be more depressed than other students. Maybe even another way that we could look at it is maybe organizing students according to hair color, right? So, and this is kind of a weird one. I don't know if there'd be any rationale for doing this, but maybe are students who are brunettes more or less depressed than students who are blondes? Kind of an interesting question to ask. Okay, so that's the first way that we can organize data in terms of nominal data. The thing that you want to get here is that the data is being organized by category, and here are some examples of different categories that could be used. Okay, so then the second measurement category, according to the noir system, is ordinal data, right? It's the O in noir. Here the definition is you're going to organize data by ordered categories, right? So here we're saying that you may have information on direction. So what are some examples of this? One example could be in terms of, let's say, write down examples here. Let's say maybe in terms of preference order, right? So how do you like things? Let's say maybe we go out and we ask people like, what is your favorite cereal. And we ask them to tell us their first favorite cereal, their second most favorite cereal, and their third most favorite cereal. Here we're still talking about categories, right? Because first, second, third, those are categories. But now we're talking about ordered categories in that this comes first, that comes second, that comes third. Maybe just to give you another example of this, we could say another ordered category would be something like military rank, right? So maybe we only want to ask students that are maybe soldiers or sailors at BC or veterans at BC. And so we'd ask them, okay, before we even ask you how depressed you are, we want to know what rank you had in the military. This would be ordered in the sense that you've got first private, I think then corporal, then sergeant, and so on. Okay, so let's go ahead and move on to the third type of measurement category then. And that is interval data, right? So we're on the third, we're on the I of noir. Interval data is identified now as where now you have ordered categories but with equal intervals between them. Thing that we can add to this is that now what you have is information on magnitude and direction. So what are some, and you also have this idea of no absolute zero, right? And I'll explain what that means in a moment. Let's do it with our examples. Right, so what are some examples of interval data then? Well, one example would be that what I just referred to in that earlier example of having a scale of 1 to 10. By the way, this is referred to as a Likert scale, right? So when we go out and we ask questions of our participants, they can only give answers between 1 and 10. In that sense, there is no zero available to that participant. They can't give you an answer of 0 because it's not available as an answer. But then there are other ways where 0 cannot be a possible answer. Let's think, for instance, of a second example of interval data of temperature. Right, so here we can ask, we can go out and ask people, what is your temperature, right? Maybe even give them a thermometer. This would be an interesting question to ask in this time of COVID, where a high temperature is a sign of having COVID. But how would temperature be an example of interval where you don't have any absolute zero? I mean, you can have a temperature of 0. You'd probably be dead, but you could have a temperature of 0, right? It is possible for that to exist. What we mean with this, though, isn't so much that you can have a temperature of 0. What we mean is that you cannot not have a temperature, right? No matter where you are at in life, you have to have a temperature. It could be 0, but the thing that we're saying is that temperature cannot be missing. There cannot be no case of no temperature. And so that's how we mean there's no absolute 0 here. Okay, so let's go ahead then and move on to the fourth type of measurement category, the R in noir. And that stands for ratio data. Here we define it as now where you have interval scale, right? So you have that third type of scale, but where you can have an absolute 0. So what are some examples of this? Well, an example is, put the word example here, is that now you can do things where you can go out and ask people questions and their answers can be 0 in the sense that there's nothing there. One example is you can go out and ask participants, how much money do you have? Right? And now here, we're saying that money is an example of ratio data because it's possible for someone to say that I have nothing or I have no money. Let's think of other examples where this is the case. Maybe you want to ask them, and this is all kind of related to whether they're depressed or not. Are you on any type of medication? Right? So are you presently taking a medication? They could tell you, okay, and so the answer would be like, if they are taking a medication, they're going to give you an answer in terms of a dose, like how much medication they're taking. You can have 0 here, where that 0 represents no medication. Okay. Okay. So let's go ahead and say that we're now done talking about the 4 different kinds of measurement categories. We will be coming back to these quite a bit, so you do want to have a solid sense of what nominal, ordinal, interval, and ratio are as we move on throughout the semester. For right now, though, I now want to talk about different types of variables that we can be looking at. First, let's just remember that a variable is anything measurable. Right? That's what a variable is. And it's just up to the psychologist to determine, well, how do we go about measuring different variables then? So we could say a first kind of variable that we can talk about is the independent variable. This is that thing that I was referring to as an IV earlier. Let's just simply say that an independent variable is something that you only see in experiments. Because in experiments, that's where the researcher has done something to a participant. So the independent variable is that thing that the researcher does to the participant. One thing that you want to note with this is that when you talk about the independent variable in an experiment, you always want to talk about it in terms of this measurable quality, right? So for instance, in our example before, we said that it was the administration of the antidepressant. So with here, what you'd want to talk about is how much of the antidepressant was administered to the participants, right? Was it a low dose, a medium dose, or a high dose? And that's the thing that the researcher is interested in looking at. What effect on the person's level of depression do those different doses have on the participant? So then the second type of variable that we can talk about is the dependent variable. And this is what I had referred to as the DV earlier. So again, this is a type of variable that is only seen in experiments. And in an experiment, the dependent variable is the measure of the participant's reaction. Right? So in our example before, we said that it was the measure of the effect of the antidepressant on the depression. Right? So what we could do here is we'd say, okay, we've administered some antidepressant to participants. We've measured how much antidepressant they got. And so now we're going to measure the effect that antidepressant is having on depression. Maybe we'll ask them to report the level of depression in terms of that scale of 1 to 10 again. Okay. But beyond the independent variable and the dependent variable, there are other kinds of variables as well. 2 that I want to talk about in particular. One is what's referred to as the discrete variable. Now here we're talking about a variable that can be used in any study. It doesn't matter. It can be used in correlation, it can be used in an experiment, whatever. The thing that we're saying here though is it's going to be a specific type of number. It's going to be a number that was acquired through counting. And that's how the number was created. Very important quality to this is that because you counted this, you can't have, or you have to have these indivisible categories. What do I mean by indivisible? I mean that you can only have the thing or nothing. You can't have a part of the thing. You can't have half, you can't have a third, you can't have some kind of fraction. You can only have the thing or no thing. That's what we mean by indivisible. Okay, so kind of a hard concept to grasp. So let's think of some examples of discrete variables then. One example is the number of students in class, right? So the discrete variable that we have is talking about the number of students in class. This is a variable in that it's something that's measurable. But how is it measurable? It's measurable by counting. Notice what we were saying about the indivisible part is that when you go to count students, you can't have a half of a student or 3/4 of a student. You either have a student or no student. And that's what we mean by this indivisible quality. Another example of this would be something that's kind of unique to psychological analysis. But we'll say it is the number of acts of SIB. Right, so this is something that researchers are often interested in studying, acts of SIB. I'm wondering if anyone is listening to this lecture or watching this lecture knows what I mean by this term SIB. In psychology, this is an often measured variable, refers to self-injurious behavior, right? So here what we'd be measuring or we'd be counting is the number of times that someone did something to themselves that was harmful. Something that you see quite often with people experiencing depression. I'm sure you've heard of that term cutting, which is where someone will like cut themselves with a knife or some other, like maybe a razor blade. And it's to help them not feel as psychologically depressed. They're focusing more on this physical pain and distraction from the psychological pain that they're experiencing. Right, but it's an indicator that someone is depressed, and so it's often a variable that researchers like to measure. How are they going to measure it? They're going to measure it by counting the number of acts that have occurred. Notice again, there's this indivisible quality here in that you either have an act or no act. There's no half of an act. Okay, so let's go and move on to the fourth kind of variable that we can talk about now. That is the continuous variable. Here, I'm defining it as in any study, right? So not just an experiment, but in any study, this is a number acquired by measuring, right? So you're actually going to do measurements here. This consists of categories that now are divisible, right? So now with continuous variables, you can have fractions or decimals be data. So what's some examples of this? Let's go ahead and write the word examples here. And we'll just note some examples are things like a person's height, right? And this would be a very interesting variable to measure, again, when we're talking about depression. You might be asking like a correlational study where you go up to people and you ask them, how tall are you? And then you relate that to whether they're depressed or not. One thing that I would get, or that I would theorize may be possible, is particularly if you're talking to like a male student, the shorter students may be more depressed than the taller students, right? It seems like with men, level of attractiveness is a very important characteristic. Shorter men may feel less attractive than taller men, and then they also may feel more depressed as a result. Interesting theory. I would certainly like to study it. I'm not saying it's true, but I think it would be interesting to study to see if it is true. By the way, I'm a really short guy. And I often feel, well, less attractive because I'm short. But anyway, another continuous variable that we could look at would be time. Right here again, you're measuring, or you're gathering data by measuring, maybe like how long something has lasted. Seems like there's a lot of instances where this could impact a person's level of depression. Maybe, for instance, how much time it takes them to complete their homework. Maybe people who feel like it takes longer for them to complete their homework are more depressed than people who take a shorter time to complete their homework. Let's also notice the divisible quality here as well. Here we're talking about height. You can have fractions or you can have parts of height. Often we talk about height in terms of like feet. Let's talk about instead in terms of like the metric system. In the metric system, I think they often use centimeters to talk about height. You can have 50.5 centimeters as your height, and there's that divisible quality. Same thing here. You can complete your homework in 2 hours, or you can complete your homework in 2.5 hours. There again is that divisible quality. Okay, so at this point we've talked about 4 different kinds of variables that you want to know about. Now I'm going to go ahead and wind this lecture down by just noting some important symbols that you want to know throughout the semester in this class. And I'll start with the first symbol first. That is the uppercase letter X. X will always be used to refer to scores for a first variable, right? So in this class, we're often going to be talking about correlational studies, experiments, studies where maybe more than one variable is being studied at a time. So in those cases, X will always represent the group of scores for the first variable. Let's think of it maybe in terms of that correlational study, right? So in our correlational study, I went up to all of the 24 students in the class and I asked them, how long have you been a BC student? So what I got was 24 people telling me how long they were BC students. That collection of 24 answers can be referred to as my X score. So then let's now look at the second symbol that you want to be aware of in this class. The second symbol is the uppercase letter Y. Here, we're just saying that this is going to be now a different set of scores that will be used to represent the second variable in the analysis, right? So going back to our example of the correlational study, we went up to students, we asked them 2 different questions. The 24 answers that we got to the first question are represented by X. The 24 answers that we're going to get for the second question can be represented by Y. Okay, so let's just remember, X represents all 24 answers that you got for this question. Y represents all 24 answers that you got for this question. Next symbol that we want to make sure that we understand is the uppercase letter N. Here we're saying that uppercase N represents the total number of scores in a population. Let's look where this might have been used earlier in the lecture, right? So here we're talking about population, total number of scores. Let's remember that before we had been talking about population, and then we've been talking about it is all BC students. Remember that I said that I looked at Wikipedia and I found that there were 22,000 BC students at this time. So in this case, N equals 22,000. But then from there, let's also note that there's a lowercase n. Just cover that real quick. There's a lowercase n, and this is the total number of scores in a sample. We talked about this as well, right? We said that we couldn't contact all 22,000 students for a study, so we went to the sample instead, and in the sample, there were the 24 students. So in this case, lowercase n equals 24. Okay. So now let's look at the last symbol that you want to know for this semester. This symbol is a Greek letter. By the way, you're going to get to know the Greek alphabet pretty well in this class. I think that's kind of a neat aspect of what you'll be learning. But the Greek letter that we have here is the Greek letter sigma. Anytime you see this Greek letter, by the way, this is in its uppercase form. Anytime you see the uppercase sigma, the thing that you always want to remember from that is it's saying sum of, right? Sum of something. And the way that you'll often see it is represented like this. You'll see sigma x. What does that mean? Sigma x means the sum of all of the scores in that x category, right? So you had a bunch of different answers. How long have you been a BC student? Some people said maybe 1 semester. Other people said, so 1 semester. Other people may say like 5 semesters, 3 semesters, even 6 semesters. All of those scores, right? So you got a 1, you got a 2, maybe you got a 3, you got a 4. You're going to add all those scores up according to this. And that's going to give you some total of all of those X answers. Same thing if you see sum of Y. Right? So now we're saying, oh, you also got a bunch of answers for that Y. A bunch of people telling you how depressed they were. What you're going to do, if you see this, is you're going to add up each one of those depression scores. And then you'll call that sigma Y. You may also even have a sum of uppercase N. What's that? That's going to be where you take all participants and you add them up, right? So 1 plus 2 plus 3 plus 4, all the way up to that 22,000, and you're going to get some huge number from that. Or you can have a sum of lowercase n, and that would represent, okay, for all those lowercase n's, 1 plus 2 plus 3 plus 4, all the way up to 24, and that would give you some number here. Okay, so that's everything I had to say for the Chapter 1 lecture notes about the chapter. Thank you, and I look forward to seeing you for the Chapter 1 lecture notes on the odds problems.